Today we're going to do some exponential decay problems. And you remember from yesterday that the exponential decay formula is f of t is equal to c times e to the kt, but k is negative. So the function is going to be a decreasing function. Half-life problems are typical exponential decay problems, and we'll do a couple of half-life problems. The half-life of potassium-42 is 12.36 hours. How much of a 500 milligram sample is left after 48 hours? Potassium-42 is it's important in the diagnosis of brain tumors. So a person can be given a certain milligram sample of potassium-42, and then it will decay in the body, and a certain amount will be left after a certain amount of time. So we'll figure out how much is left after 48 hours if a person has been given 500 milligrams initially. So if you remember from today, the half-life problem that we did in class, it boils down to 1/2 is equal to e to the kt, because whatever you want the final amount to be, it's always going to be equal to 1/2 of the initial amount. So you could put a 5 and a 10, or a 10 and a 20, but when you divide both sides by that initial amount, you're always going to get 1/2. So this is the formula for a half-life. And what our job is to solve for k first. And we'll solve for k because we know the time of a half-life of potassium-42 is 2.36 hours. So if you solve this for t, you just take the ln of both sides. So the ln of 1/2 divided by the time, which is 2.36 hours, that's going to be equal to our value of k. So we'll pull out a calculator, and we'll do the ln of 1/2 divided by 12.36, and I'm going to store that into my variable k. You can do that all on one line. So k turns out to be negative 0.056 with many other decimals after that. So it's negative 0.056. It's negative because of decay. This is not exponential growth. If it was exponential growth, k would be positive. So now how much is left? Now that we know k, we can figure out how much is left of a 500 milligram sample after 48 hours. So what we're doing is we're finding f of 48, because after 48 hours, t is 48. So f of 48 is equal to, and we'll use our original problem, c e to the kt. Well, t is 48. The initial dosage was 500, so c is 500. E, I'm just going to put the letter k in there, and this k value is negative 0.056. And we're going to multiply that by 48. So we don't have to do any logarithms on this part. We just put this into our calculator. So we do 500 times e to the power of 48k. And it looks like it's 33.878 milligrams. 33.878 milligrams are left in the body after 48 hours out of the 500 milligram sample that was given. So that's the first question for this. The second question for this particular problem is how long is it going to take for the original 500 milligram sample to decay down to 5 milligrams? And so we're going to be using our same formula. F of t is equal to C e to the kt. All right, F of t is the final amount that you're looking for. In this case, the final amount is 5 milligrams. So 5 milligrams is equal to C is the initial value. So we've got 500 times E. We've already solved for K. I'm just going to put the letter K. K is negative 0.056. And then we're solving this for T. So to solve for T, you just divide both sides by 500. Take the natural log of that value to get rid of the E, and divide by the K value that's been solved in our calculator. And we can come up with T, how much time is left. So we're going to do the natural log of 5 over 500, divide that by alpha K, and it looks like 82.118 hours it takes. And let's get this down to hours and minutes, since we usually don't talk about 0.118 hours. If you want to know how many minutes this is, you're going to subtract 82 to get the decimal portion of this. And if you multiply that, multiply this number, because it's 0.118 of an hour, multiply it by 60 minutes in an hour, it will be 7 minutes. So 82.118 hours is equal to 82 hours and 7 minutes. We could get it down to the second if we wanted to, but we don't want to do that. I'm going to stop the video now, and you're going to have a second video for tonight also, 2 smaller ones.